Hi everyone and welcome back. In this video, I'm going to do Affirming the Disjunct and show why it is a formal fallacy using a truth table. So affirming the disjunct has a certain form. The form of this is P or Q. Premise 2 is P, and therefore we conclude not Q. So abstract, it doesn't look like there's much going on here, and maybe it's hard to see the problem. Let's look at a verbal example, and that may help. So here's an example. I like basketball or I like tennis, right? P or Q. I like basketball, P. Therefore, I don't like tennis. So verbally, perhaps it's easier to see that this is not a good deduction at all, because it's pretty obvious that I could like both. Just because I like one does not mean I don't like the other, and vice versa. So that's a verbal example of why it's a fallacy. Although verbal examples are not proofs, so you have to show with the truth table why this is invalid. And the goal of a truth table, in particular invalidity, is to find a row where the premises are true, but the conclusion is false. Okay, so I set it up already. So I first write the variables out. My variables are P and Q. They're just two variables. And then I write each premise out, which is P or Q, P, and then not Q. And now I just fill this truth table out just like any other truth table, which means when I have two variables, I have to cover all situations, right? So true, true, false, false, true, false, true, false. Right? This part is always the same when you have two variables. Both are true, both are false, and then you mix the last two. And now you have to know a couple of rules. So this is a disjunction, which means it's true when only one of the disjuncts is true, or both. So in this case, true or true, that is true. True or false, that's true. False or true, that is true. False or false, since they're both false, this is false. Okay, now P. Well, we already have that. That's right here. True, true, false, false. Remember, we're just keeping the same situation. And the last one is not Q. We have Q, true, false, and not Q is the negation of Q, which means it's the opposite. This is true, so this is false. This becomes true, this becomes false, this becomes true. Right, we're just switching the values of these because it went from Q to not Q. Okay, now this is the argument in truth value or truth table form. So the goal is to find a case where the premises are true, but the conclusion is false. Right? If you can find that row, then you can prove to me that this whole thing is invalid. So let's look. True, true, false, right here. This is the row. Let's highlight that, maybe in some red, blue. Let's go yellow. So this is saying, hey, P1 is true, P2 is true, but your conclusion is false. That means that your conclusion does not follow from your premises, right? A valid argument is supposed to work that way. It's supposed to not show something like this. So that's pretty much it. You just have to be able to understand and interpret what this is all saying. So again, just to make sure it's really clear, these four cases are the four possible ways the situation can happen. Both can be true, both can be false, or some mixture. And then you have to prove that there's one case, at least one, there could be more than one, at least one case where the premises are true and the conclusion is false. If you can prove that by showing an example just like this, then that is a truth table proof. This verbal example is really more to help your intuition to convince yourself that it's false. And maybe seeing it this way is not helpful. Maybe seeing the symbolic format is not that helpful. So being able to take the symbols, turn them into words, understand those words, and then being able to throw it into a truth table and prove definitively that your argument is invalid. So that's pretty much it for this video. If you like the content, be sure to like it on YouTube, and I appreciate it. Thanks so much. Bye.